Ever wondered what secrets the red planet holds? What has propelled us to explore its dusty crimson terrain? Indeed, Mars has always been an object of fascination, a mystery waiting to be unraveled. This celestial body, forth from the sun, has been at the heart of human curiosity for centuries. Mars, with its stark red appearance and intriguing features, has often been the muse for countless sci-fi tales and space expeditions. But why this persistent fascination with Mars? Well, it's not just about the allure of the unknown. Mars represents a potential answer to some of our most profound questions. Is there life beyond Earth? Can humans survive on another planet? These questions have driven the objectives of Mars missions, each one striving to peel back a layer of the Martian mystery. From seeking signs of ancient life to understanding the planet's climate and geology, each mission takes us a step closer to comprehending this enigmatic neighbor of ours. So join us as we journey through time, retracing humanity's quest to understand Mars. The first attempts to reach Mars date back to the 1960s. As we cast our minds back, we find ourselves in the heart of the space race, a time of intense rivalry and incredible innovation. The red planet, with its alluring mystery and tantalizing potential, became a prime target for exploration. NASA, the American Space Agency, was among the first to set their sights on Mars. Their Mariner missions, starting with Mariner 4 in 1964, were ambitious attempts to reach out and touch this distant world. Mariner 4 was the first successful mission to Mars, sending back 21 precious photos of the Martian surface, a glimpse of a world that had until then only been seen through telescopes. Yet these early missions were far from easy. The journey to Mars is a long and treacherous one, fraught with numerous challenges. Spacecraft had to travel hundreds of millions of miles, braving harsh radiation, extreme temperatures, and the ever-present risk of equipment failure. Many missions, like the Soviet Mars program, met with little success, their spacecraft either failing to reach Mars or losing contact soon after arrival. Despite these challenges, the early Mars missions were not in vain. Each setback was a lesson learned, each failure a stepping stone towards success. These missions tested and pushed the boundaries of our technological capabilities, teaching us invaluable lessons about interplanetary travel and paving the way for future expeditions. They also sparked our collective imagination, fueling a sense of wonder and curiosity about the universe. The images sent back by Mariner 4 and its successors showed us a world both alien and strangely familiar, with landscapes reminiscent of Earth's own deserts and canyons. These tantalizing glimpses of Mars spurred on further exploration, igniting a drive to uncover the secrets of the red planet. These early missions laid the foundation for future explorations, sparking a drive to conquer the unknown. They marked the beginning of humanity's quest to explore Mars. A quest that continues to this day and promises to reveal even more about our intriguing neighbor in the cosmos. As technology advanced, so did our ability to explore Mars. Our journey to the red planet truly began to gain momentum in the mid-70s with the Viking missions. These twin spacecraft, Viking 1 and Viking 2, were the first to successfully land on Mars, providing us with our most comprehensive look at the Martian landscape up until that point. The Viking missions made several groundbreaking discoveries. They revealed the existence of water vapor in the planet's atmosphere, providing the first hint that Mars might once have supported life. Yet, the Viking missions were just the beginning. The 90s brought about a new wave of Mars exploration, with missions such as the Mars Global Surveyor and the Pathfinder. The Mars Global Surveyor orbited the red planet for nearly a decade, mapping its surface, studying its weather patterns, and providing scientists with a wealth of data. The Pathfinder, on the other hand, was a pioneering mission in its own right. It landed on Mars in 1997, carrying with it the Sojourner rover. This was the first time we had sent a mobile robot to another planet. The Sojourner rover, though small, had a big job. It was tasked with analyzing the Martian rocks and soil, searching for signs of water and life. Despite its short operational time of just 3 months, Sojourner sent back valuable data that significantly contributed to our understanding of Mars. These missions, Viking, Global Surveyor, and Pathfinder, not only increased our knowledge of Mars, but also tested the limits of what was technologically possible. They showed us that we could land a spacecraft on another planet, that we could orbit and map that planet, and that we could send a robot to roam its surface. In essence, these missions laid the groundwork for all future Mars exploration. They demonstrated what we were capable of and gave us the confidence to push even further. These missions gave us our first real glimpses of Mars, fueling our curiosity and determination. The dawn of the new millennium brought with it a renewed vigor in Mars exploration. This period marked a new chapter in our quest to understand the Red Planet, with missions like Spirit, Opportunity, and Phoenix taking center stage. The Spirit and Opportunity rovers, twin robots launched by NASA in 2003, were designed to explore the Martian surface for signs of past water and possible life. Spirit roved the rugged Martian terrain for 6 long years, far exceeding its initial 90-day mission. It found evidence of past water in Gusev Crater, a discovery that shook our understanding of Mars. Its twin, Opportunity, performed even beyond expectations. For nearly 15 years, it traversed the Martian landscape, uncovering signs of ancient water and reshaping our perception of Mars as a potentially habitable world. Its most significant finding was the discovery of hematite, a mineral that typically forms in water, suggesting that Mars once had a wet environment. In 2007, NASA launched the Phoenix Mars lander. Unlike its rover siblings, Phoenix remained stationary, but its mission was no less important. It was tasked with studying the history of water and the habitability potential in the Martian Arctic's ice-rich soil. Phoenix's findings were groundbreaking. It confirmed the presence of water ice in the Martian subsoil, strengthening the case for Mars as a planet that could have once harbored life. These missions, each unique and groundbreaking, opened our eyes to the wonders of Mars. They unveiled a planet with a history of water, one that might have been habitable in the past. And they did more than just explore. They inspired. They sparked imaginations, fueling dreams of future manned missions to the Red Planet. These missions pushed the boundaries of our knowledge, bringing us closer to answering the question, is there life on Mars? The past decade has seen some of the most ambitious Mars missions yet. As our technology evolves, so too does our ability to explore the alien landscapes of the Red Planet. Take the Curiosity rover, for example. Launched in late 2011, Curiosity's primary goal was to investigate whether Mars was ever capable of supporting microbial life. It was a mission that completely changed our understanding of the planet. Its findings, including the discovery of an ancient streambed where water once flowed, have helped us piece together Mars' wet past. Then there's MAVEN, short for Mars Atmosphere and Volatile Evolution. This mission was designed to study the Martian atmosphere, and boy did it deliver. MAVEN's observations have been instrumental in understanding how Mars lost its atmosphere and water, transforming from a world that could have supported life billions of years ago to the cold, barren planet we see today. More recently, we've seen the launch of the Mars 2020 mission, which brought us Perseverance and Ingenuity, the rover and helicopter duo. Perseverance's mission is to seek signs of ancient life and collect samples of rock and regolith that could one day be returned to Earth. Ingenuity, on the other hand, took to the Martian skies, demonstrating that powered, controlled flight is possible on another planet. But we're not stopping there. Plans for future Mars missions are already in the works. The ultimate goal? Human exploration of Mars. NASA's Artemis program aims to return humans to the Moon by 2024 as a stepping stone for future Mars exploration. Meanwhile, SpaceX's Starship is being designed with the intention of carrying humans to the Red Planet, possibly as soon as the late 2020s. As we stand on the brink of a new era in Mars exploration, we can only wonder what secrets the Red Planet still has in store for us. With every mission, every discovery, we're not just learning about Mars. We're learning about our place in the universe, about our past, and perhaps about our future. The journey to Mars is far from over. We've delved into the mysteries of the Red Planet, traced the footsteps of early expeditions, and celebrated the triumphs of modern Martian missions. Each step has been a testament to human curiosity and our relentless pursuit of knowledge, yet the fascination with Mars remains as strong as ever. Its crimson allure continues to beckon us, inviting us to unveil the secrets it holds. The future missions to Mars are not merely quests for exploration, they are also quests for self-discovery. We hope to find answers to some of the most profound questions. Could Mars harbor life? What can it teach us about our own planet's past and future? As we venture further into the cosmic abyss, we strive to decipher the cryptic messages that Mars sends us. As we continue to explore Mars, we are not just seeking to understand another planet, we are seeking to understand ourselves,